Alrighty, y'all. I'm going to go through some of the problems that were assigned by Mrs. Scott on the Pythagorean theorem. Now, personally, I like the Pythagorean theorem because I'm an old guy who's done a lot of math, but I remember when I was a student, I found it kind of confusing because it's full of letters, right? So the Pythagorean theorem states that. Hold on. Let me get a pen here. Let me erase that. The Pythagorean theorem states that a squared plus b squared equals c squared. All right? Why is this confusing? Well, it's confusing because we're talking about math and this is all letters. It's also a little confusing because when I look at the problems that were assigned by Miss Scott, I don't see A, B, or C on any of these triangles. So that's the first thing I need to figure out. Which one of these letters belong to which sides of the triangles? That's super confusing. One thing that I do remember Miss Scott saying, I'm pretending that I was in her class earlier in the year, was that one of the letters belongs to a side of the triangle called the hypotenuse. All right? So, one thing you'll notice in all of these triangles is there's a little square. All right, we got a little square here. In number 8, we've got a little square here. In number 7. And the hypotenuse is the side that's directly across from the right angle. All right, so it would be 30 in number 8, and it would be 21 in number 7. And you can kind of go through that with each of the numbers 1 through 9. In fact, I'm going to go through and just highlight the hypotenuse so that I know which side belongs to letter C. So we got boop, boop. I'm not going in order here, as you can tell. We got 24 is the side directly across from the right angle. And number 4, it's 10 is across from the right angle. And number 6, X is across from the right angle. And number 5, X is across from the right angle. And number 2, it's X. And in number 1, it is also X. And in number 9, actually each one of these sides could be across from the right angle or is across from a right angle. So depending on which triangle you're trying to solve for, there you have it. All right, so that's your challenge problem. This will be your challenge problem after I go through a couple examples and you go through them as well before you submit them to Miss Scott. All right, so we're going to pick a couple of these and go through them together. And I am thinking that I would like to do number 2. Let's do number 2. All right, so I'll do number 2. And then we'll also do number 4. All right, so we'll do number 4 as well. So starting off with number 2, the first thing I like to do is always write the Pythagorean theorem, which says that a squared plus b squared equals c squared. All right, then I'm going to plug in what I know. Now remember, guys, the c belongs to the hypotenuse. All right, so the c is actually our x value. So I'm just going to plug in what I know. So instead of calling it c, I'm going to call it x because that's what it's called in the problem. All right, and instead of calling one side A or one side B, it doesn't really matter which side is A or B. The 10 could be A, the 10 could also be B. The 24 could be A, the 24 could also be B. So it's kind of whatever you decide. So I'm going to call A the 10, so we'll do 10 squared, and we'll call B 24 plus 24 squared equals x squared. Now I just need to simplify until I'm eventually going to end up with x equals a number, and then I will know how long my hypotenuse is. All right, so 10 squared equals 100. We got 24 squared, so that'd be 24 times 24 equals 576 equals x squared. All right, so I'm getting closer to finding out what x is. I'm going to simplify this left side a little bit more, so I got 100 plus 576 equals 676, and that's equal to x squared. Now this can be a little tricky because I have x squared equals 676, or 676 equals x squared. So how do I get x by itself? Well, if I have x squared, in order to get x by itself, I just take the square root of that. Now, if I take the square root of what's on the right side of that equal sign, I need to also take the square root of what's on the left side of the equal sign so that the equation remains balanced. All right? Now I'm going to come up here. Sorry, I don't have enough room on my screen. But when I take the square root of 676, what I end up with is, hold on, let me get my calculator. Got to turn my phone sideways here. We got 676, and then, so the square root of 676 is 26, and that equals C. So for number 2, the side that belongs to the variable x, which is the hypotenuse, ends up at 26. All right? So I'm going to erase what I've got here and then go through number 4 with you guys. And then hopefully that will allow y'all to carry on and complete the rest and then do that number 9 challenge problem. All right, so we got number 4. All right, so number 4, we've got let me write my Pythagorean theorem. We got x squared. Sorry, I'm confusing myself. Do red. So we got a squared plus b squared equals c squared. All right, so which side belongs to A, which side belongs to B, which side belongs to C. So looking at number 4, we've got the hypotenuse is highlighted as 10. I know that that is going to be my C value. So I'm going to go ahead and put 10 squared for my hypotenuse. Now, the A and the B can be any ones I pick that are remaining. So I'm going to go ahead and call A the x, so it'll be x squared, and then I'm going to add 6 squared to that. And then I'm going to start to simplify on each side and eventually end up with x equals a value, which will tell me what that missing side is for number 4. All right, so 10 squared equals 100. We got 6 squared equals 36 because 6 times 6 is 36. And then we've got x squared added to that. So x squared plus 36 equals 100. All right, so now I need to use something called inverse operations to continue to isolate the x value. And what I'm going to do is I am going to first get rid of the 36 because, again, I want to end up with x equals, and getting rid of the 36 is my next best step. All right, so in order to get rid of it, I'm going to do the opposite. And right now it's being added, so the opposite or the inverse of addition is subtraction. So I'm going to subtract 36. If I subtract 36 from this side of the equation, sometimes it's helpful to put a line down the middle so you know that there's 2 distinct sides so you don't forget to do the same thing on the other side. So if I subtract 36 on this side, I need to subtract 36 on this side. And then what I end up with, I'm going to write over here because I ran out of space. So the 36 minus the 36 goes away, and I end up with x squared equals 100 minus 36 equals 64. All right, and as we did in the problem before, if I have an x squared, in order to get that down to an x, I need to take the square root of that. If I take the square root of the left side of the equation, I need to take the square root of the right side of the equation so that that equation remains balanced. All right, and that's going to give me x equals 8 because I know that 8 times 8 equals 64, and that is the missing length for number 4. All right, so that's it for today. Hope this is helpful, and we will talk to you guys soon. May the force be with you.